So to solve this exercise, remember you have to read this and you have a dihybrid cross and you are crossing this, and this has something very particular, and I want that you analyze which one are dominants and which one will be recessive, which one are recessive. And you have that S is dominant, but so it's similar to what Mendel did, but the gene Y is different, and you have to assume independent assortment. So they are asking you this question: how many phenotypic classes are expected in F2? Okay, this question is slightly difficult, but let's try to solve it together. This is an example of epistasis, and I'm not going to make many difficult examples of epistasis, but I want that this is a simple one, and I think that you can solve it. You mainly here, I am asking you that if you understand what is a dihybrid cross. So let's do it together. First thing that you have to do is set up the cross, and if you see here, you have dominant, and here dominant, and here you have the recessive one. So recessive. So it's very interesting. Why? Because if you cross this, what are you going to get? You're going to get this one. So you are going to get the double heterozygous. And if you self-fertilize this one, this is exactly what Mendel did. So you get the 9331. And here you are supposed to get 1, 2, 3, and 4 phenotypes. However, as we don't have complete dominance in the gene Y, here you are going to get more than 4 phenotypes. Yeah. So let's do let's see why. So here is the same exercise that Mendel did. You have 4 phenotypes. However, when you have a heterozygous here and a heterozygous here, something new will happen. Yeah. So you're going to have, for example, round, wrinkle, but when you have a heterozygous, you can start creating something, I don't know, smooth, square, give the name that you want, but you get an additional phenotype because there is not a complete dominance there. There is a different degree of dominance. So in other words, you get one here and an additional here. So here you have 1, 2, 3, 4, 5, and 6 uh, phenotypes. So it looks complicated, but as you see, it was not as complicated, and you just have to apply what you learned from Mendel. First, that when you have a dihybrid cross, so when you cross pure lines, then that is dihybrid. Let me put it right here, dihybrid. You are going to get a heterozygous, a double heterozygous in this case. Here we got the double heterozygous in a different way, and this one will produce a ratio of 9331. However, as it was not complete dominance, instead of getting these 1, 2, 3, and 4 genotypes, you are going to get 2 additional ones, so you are going to get 6 phenotypes. Okay, so now let's move to the next question, and if you have any doubt, just send me an email. Okay, this is a slightly longer question, and please read it, but remember I highlight 3 important things for you here. Okay, now that you read the question, I remind you that as we watch in the video, sex determination sometimes is more complicated than we thought before. So in males, they could be is different one. You have when you have 2 similar, you get a male, while in humans XX is a female. In females, they are different, the 2 chromosomes, and here, so you have males, females, and here you have a lethal allele that is recessive. So that is important. So every time that you have this one, you have a recessive allele. So they're asking you, what is the sex ratio of the offspring when you cross a male heterozygous for the lethal allele and a normal female? So that is fundamental. That last part, you have to set up this cross based on this male heterozygous for the lethal allele and a normal female. So let's do it. Male and female. The male is heterozygous for the lethal allele, as you can see here, and the female has only one allele that is normal. So you will get the following. This is the following Punnett square, and if you remember, this one that have only one allele, this it will be lethal, yeah, because it only have one set. As a result, you are going to get two males and you're going to get only one female because one of them died. So your ratio will be 2 to 1, two males to one female, and you will have one that dies.